let's take a look at the last two examples. So I have 3 over 5, negative 4 over 25, 5 over 125, and so on. So once again, I'm going to start by making my table with my natural numbers. So 1, 2, 3, 4, 5, and a spot for the nth term. Okay, and then my ace events, I have 3 over 5, negative 4 over 25, 5 over 125, negative 6 over 625, and 7 over 3125. Okay, so the thing here that looks the easiest to me is these denominators, because I know 25 is 5 times 5. If I multiply again, I get 125. So these denominators here, this looks like 5 to the first, 5 squared. Okay, and then I have my numerator to deal with. So I'm going to start by just looking at the numbers, so not the signs, but the actual just numbers. So I have a 3, a 4, a 5, a 6, and a 7. So these are counting up by ones. So when n is 1, I have a 3. When n is 2, I have a 4. When n is 3, I have a 5. So this looks to me like this is n plus 2. Right? So when n is 1, 1 plus 2 is 3. When n is 2, 2 plus 2 is 4. So that looks good. Then the last thing I have left to deal with is the signs in the numerator. So I have a positive, a negative, a positive, a negative, a positive. So I'm alternating signs. And we saw something like this earlier. We saw that when we looked at this very last sequence on here. So we had a negative, a positive, a negative, a positive. And the way that that was worked in there was with a negative 1 to the n. So this is kind of the most common way of having terms that alternate. So this would be an alternating sequence. And we're also going to look at alternating series a little bit later on in this chapter. So you'll see this idea again. So I want to use this negative 1. Say no, I need a negative 1 here. But if I do negative 1 to the n, when n is 1, I get negative 1 to the first, which is negative, and I need it to be positive. So I'm going to make it negative 1 to the n plus 1. Okay. You could also do negative 1 to the n minus 1. That would work as well. You just need to offset it so that you're getting the signs going positive, negative, positive. Okay. All right. So that's example 4. Example 5. So negative 2 over 3, 3 over 9, negative 4 over 27, 5 over 81. I want you to take this one and give it a try on your own. So you're going to pause and give it a try. All right, so hopefully you gave that a good try. Let's go ahead and do this one. So again, I'm going to make my table. So I have my n's. So 1, 2, 3, 4, and then a spot for my nth term. And I'm going to put my terms in here. So I got negative 2/3. I have a 3 over a 9, a negative 4 over a 27, and a 5 over 81. All right, so I'm going to start with the numbers in the numerator first. So the numbers just go, if I ignore the sign, is 2, 3, 4, 5. So we're just counting by ones. So when n is 1, I get a 2. When n is 2, I have a 3. So I'm going to call this n plus 1. Okay. And then I've got the signs going again. So my signs are going negative, positive, negative, positive, which is the exact opposite of the last one. So I'm going to do negative 1 to the n, also in my numerator. So if we think about that, negative 1 to the first is a negative 1. Negative 1 squared is going to be a positive 1, so we're going to get the signs that we need. Right, that just leaves the denominator. So I see a 3. I know 9 is 3 times 3. 27 is 3 times 9, which is 3 times 3 times 3. 81 is 9 times 9, which is going to give me 3 to the 4th. So my denominators look like 3 to the 1st, 3 squared, 3 cubed, 3 to the 4th. So I'm just going to call the denominator 3 to the n, and hopefully that's what you got for your function.